This is the pre-lab section. The first question is in the statement delay microseconds 2000. What does 2000 stand for? 2000 is the number of microseconds to wait before executing the next piece of code. So it's basically a pause command with the number being how many microseconds to pause for. Analog write and digital write. So analog write is going to use pulse width modulation, which basically the Arduino can only output 5 volts, so it turns 5 volts on and off at a certain frequency to basically make a square wave, which is like a pseudo voltage between 0 and 5. The digital write basically is just 0 or 5 volts, high or low. In the Arduino on the right, so the analog pins are 3, 5, 6, 9, 10, and 11, which have a tilde next to them. The digital pins are 2 through 13, so all the pins, the output pins, could be used for digital write because an analog pin also functions as a digital pin because all it will be doing is outputting full 5 volts. And then a call to analog write is on a scale of 0 to 124 because it's using an integer, which I believe is a 16-bit number. And the Arduino's pulse width modulation frequency, as you can see on the website on the right, the Arduino website, the Uno board pulse width modulation pins are normally 490 hertz, but pins 5 and 6 specifically operate at 980 hertz. So you get a higher frequency out of those two pins specifically. This is a demonstration of my Blink program. This is Blink Faster with a delay of 10 milliseconds between turning on and off. And this is about the limit where I can't tell with my eye that the light is actually changing state. This is the fade program, and the brightness integer actually seems to determine the beginning brightness of the LED and doesn't actually prevent it from turning fully on and fully off, meaning 0 to 255 as the input for the pulse width modulation. This is my custom fade program, which can go through 3 different frequencies. The first one being slow, the second one being about the 2 millisecond fade, and the third one being basically fast enough that you can't tell it's blinking. So it blinks twice when it reaches peak brightness and when it turns off completely. So you can see it going through frequency 1, 2, and 3, and now on frequency 3, it's basically just blinking continuously because the ramping up and down of brightness is quick enough that you really can't see it happening. This is my custom code for number 5. I have a potentiometer being read into the Arduino, which is also lighting up an LED depending on the resistance across the potentiometer. And then based on what it reads in from that potentiometer, it'll output the voltage it's calculating based on that integer. And then that voltage will be output to a computer fan that I had laying around. And as it turns on, I turn the potentiometer, I'll light up the LED and turn on the fan. Oh, my fan's a little sticky. The fan activates around a couple volts, maybe like 2 or 3 volts is the threshold to really get it actually turned on. You could see the LED. The fan also changes speed depending on how much voltage is input to the on that pin.